Okay, so you're reading the newspaper, you're watching the news, and they're talking about some new medical technology, some breakthrough treating congestive heart failure, or regrowing muscle tissues in wounded soldiers. I bet you that story is going to mention that this new type of therapy uses stem cells. And I bet you, like most people, are gonna listen along and be like, yeah, oh, yeah, oh, yeah. Without actually knowing what stem cells are, because who has time to know what stem cells are? Today, we're making time. You got lots of different types of cells in your body. You got muscle cells and skin cells and liver cells and brain cells, and most of these cells have to be replaced every once in a while. Your taste buds, for instance, are replaced every 10 days or so. Skin cells are replaced every couple of weeks, and liver cells turn over every 300 to 500 days. The cells that are doing the replacing of the old cells and the repairing of the damaged tissues are adult stem cells, also called somatic stem cells. The different sorts of cells, skin cells, liver cells, retina cells, muscle cells, intestine cells, they all have very specific jobs, and they're built in very specific ways to do those jobs. Different shapes, sizes, contents. You can't just stick a muscle cell into a damaged liver and expect it to start breaking down your alcohol for you. Somatic stem cells, on the other hand, haven't decided what the heck they're gonna be. They're undifferentiated. They haven't specialized yet, like a college freshman. Or, let's face it, a recent college graduate. They have no idea what they're going to do with their lives. But just like there are different types of college graduates, there are different types of adult stem cells. Some can become more different kinds of things than others. Pluripotent stem cells can become many different types of cells all over the body. However, they're really hard to track down because there are so few of them in each organ or tissue. There are also multipotent adult stem cells, which are more common in the body, but restricted in the kind of cell that they can become. It's kind of like the difference between graduating from a trade school, where you've been trained to do a few different possible jobs, and graduating with a degree in philosophy or something, equally unprepared for all jobs. So yeah, stick a pluripotent cell in a damaged liver, and it just happily becomes a liver cell. Pretty cool. But there are some even better types of stem cells to be had, embryonic stem cells, which are also pluripotent. These are the cells inside a human embryo when it's a blastocyst, basically just a tiny nugget of human cells 4 or 5 days old, which is destroyed in the process of removing the stem cells from inside it. These embryonic cells are obtained from in vitro fertilization clinics that fertilize eggs outside of a mother's body for couples who are having trouble conceiving. Naturally, these clinics have some leftover fertilized eggs, so with the donor's permission, they're given to scientists doing stem cell research. Now, the main advantage of the embryonic stem cells is that while adult stem cells can be grown in culture for a time, meaning they can be made to multiply over and over in a nutrient solution, they can't grow for as long or as fast as the embryonic stem cells, which can be maintained indefinitely under the right conditions. After just 6 months in culture, a single wad of 30 embryonic stem cells will have yielded millions of stem cells, which can go on to develop pretty much into any type of cell in the body. Also, adult stem cells, if used in some sorts of transplant therapies, are more likely to be rejected than embryonic stem cells. Stem cell research is currently pretty hoppin'. Embryonic stem cells are being used by researchers all over the world to figure out how to repair or replace damaged cells and organs and create new drugs. But regulations have taken their toll. There are only about 35 stem cell lines or families of identical pluripotent stem cells that are available for federally funded research in America, whereas Europe has a couple thousand. So there, now you'll never have to your way through another news report about stem cells again. Thanks for watching this episode of SciShow. If you have any questions, comments, or suggestions, you can find us on Facebook and Twitter, or of course down in the comments below. And if you want to keep getting smarter with us here at SciShow, you can go to youtube.com/SciShow and subscribe.